Welcome to the AlJazari channel, where you will learn capacity planning as a core operations management activity. In a previous video, capacity alternative evaluation using the break-even analysis method is explained. If you wish to watch that video, click the above link. Here a solved problem to compare two alternatives is presented. A small firm intends to increase the capacity of a bottleneck operation by adding a new machine. Two alternatives, A and B, have been identified, and the associated costs and revenues have been estimated. Annual fixed costs would be $55,000 for A and $25,000 for B. Variable costs per unit would be $9.25 for A and $12.50 for B, and revenue per unit would be $16. Solve the following questions. A. Determine each alternative's break-even point in units. B. At what volume of output would the two alternatives yield the same profit? C. If the expected annual demand is 14,000 units, which alternative would yield the higher profit? The givens are as follows. The fixed cost for alternative A, FCA, is $55,000, alternative B's fixed cost, FCB, is $25,000, alternative A's unit variable cost, VA is $9.25, the unit variable cost of alternative B, VB is $12, and the revenue per unit, R, is $16. For a better understanding of the problem, let us plot the lines representing the total cost of alternative A, the total cost of alternative B, and the revenue. It is clear that there are 3 points of intersection. The first one is the intersection between the revenue and alternative B's total cost. We call it BEPB. While the second one is the intersection between the revenue and alternative A's total cost. We call it BEPA. These 2 points are the answer to the first question. The third point is the intersection between alternative A's total cost and alternative B's total cost. We call it BEP, and this is the answer to the second question. If you want to learn how to construct such graph using MS Excel, watch the video in the above link. Let us mathematically solve the first question. In general, QBEP equals the fixed cost divided by the difference between the revenue per unit and the unit variable cost. So, QBEPA equals FCA divided by R minus VA equals 55,000 divided by 16 minus 9.25 equals 8,148 units. And QBEPB equals FCB divided by R minus VB equals 25,000 divided by 16 minus 12 equals 6,250 units. Consequently, the first question's answer is that alternative A's break-even point is 8,148 units and alternative B's break-even point is 6,250 units. The second question is to find the production quantity at which the two alternatives yield the same profit. This means the quantity at which the total cost of both alternatives is equal or the break-even point. Generally, the total cost, TC, equals FC plus V multiplied by Q. So, TCA equals FCA plus VA multiplied by Q, and TCB equals FCB plus VB multiplied by Q. Set TCA to equals TCB results in FCA plus VA multiplied by Q equal FCB plus VB multiplied by Q. Rearrange this equation and solve for Q gives QBEP equals FCA minus FCB divided by VB minus VA. Substitute by the given values. QBEP equals 55,000 minus 25,000 divided by 12 minus 9.25 equals 10,909 units. So, the volume of output with the two alternatives yield the same profit is 10,909. Let me explain something in this graph. We have 3 points and 3 different situations. In the first situation, the production quantity, Q, is less than QBEPB, which equals 6,250, the firm will face a loss as the revenue is less than the total cost of both alternatives A and B. While in the second situation where Q is more than QBEPB and less than QBEP, alternative B is recommended because it makes a profit as the revenue is more than alternative B's total cost. Note that between QBEPA and QBEP alternative A makes a profit as well but less than alternative B's profit. And if Q is more than QBEP, alternative A is recommended as its profit is more the alternative B's profit. From this, we can answer the third question, which alternative yields higher profit if Q equals 14,000. As 14,000 is more than QEBP, so definitely alternative A will yield higher profit than alternative B. If you need to validate this mathematically, let us calculate the profit at Q equals 14,000 for the two alternatives using this equation. PA equals 14,000 multiplied by 16 minus 9.25 all minus 55,000 equals $39,500. While PB equals 14,000 multiplied by 16 minus 12 all minus 25,000 equals $31,000. So, at Q equals 14,000 units, alternative A yields a higher profit. In this video, two alternatives were compared by break-even analysis. In the next video, another problem be solved, so stay tuned and do not forget to subscribe to the channel and activate the alarm to be notified of the new videos. Thanks for watching. If you like this video, so press like and share it. See you again.